the Toba Supereruption. In 74,000 BC, deep within what is now Lake Toba in Sumatra, Indonesia, the Earth unleashed a catastrophe of unimaginable magnitude. Beneath the surface, pressure had been building for millennia. When it finally erupted, it did not merely reshape the surrounding land. It altered the destiny of humanity itself. The explosion was so powerful that it ejected thousands of cubic miles of volcanic material into the atmosphere, sending shock waves across the planet. Ash darkened the skies, and the sun itself seemed to vanish behind a suffocating veil. What followed was not just a natural disaster, it was a global crisis that nearly erased the human race. Geological evidence suggests that the Toba supereruption was the largest volcanic event of the last 2 million years. The eruption expelled an estimated 670 cubic miles of magma and blanketed vast regions of South Asia with layers of ash up to 15 feet thick. Microscopic volcanic particles have been discovered in sediment cores across the Indian Ocean and as far away as Africa. These findings indicate that the event was not localized but global in scale. Temperatures are believed to have dropped dramatically, plunging the world into a prolonged volcanic winter that lasted for years, if not decades. Sunlight struggled to penetrate the dense atmospheric haze, disrupting ecosystems and threatening every form of life dependent on warmth and photosynthesis. Genetic research presents an even more unsettling possibility. Studies of human DNA reveal a striking lack of diversity among modern populations, suggesting that humanity may have passed through a severe population bottleneck. Some scientists propose that, in the aftermath of Toba, the number of surviving Homo sapiens dwindled to as few as 3,000 to 10,000 individuals. These scattered survivors endured in isolated refuges, struggling against freezing temperatures, food shortages, and environmental collapse. If accurate, this theory implies that every person alive today descends from a remarkably small group that narrowly escaped extinction. Archaeological discoveries provide tantalizing clues. Stone tools found beneath layers of the Toba ash in India suggest that early humans survived the catastrophe, adapting to its aftermath with resilience and ingenuity. Yet the extent of the devastation remains fiercely debated. Some researchers argue that the eruption caused a near-extinction event, while others contend its impact, though severe, has been overstated. The truth remains buried beneath layers of ash and time, waiting to be fully uncovered. Despite decades of study, the full consequences of the Toba supereruption remain uncertain. Scientific reports continue to revise its climatic effects, while competing interpretations fuel ongoing debate. What is clear, however, is the sheer scale of the disaster. An eruption of similar magnitude today would disrupt global agriculture, collapse economies, and threaten billions of lives. If the Toba bottleneck theory is correct, humanity did not rise unchallenged to dominance. It survived by the narrowest of margins, clinging to existence on a planet turned hostile. And hidden within our DNA may lie the silent testimony of a catastrophe that almost erased us from history. The question remains, did humanity endure because of its extraordinary resilience, or because fate allowed it one final chance to survive? The Younger Dryas impact. In 10,900 BC, as the last ice age appeared to be drawing to a gradual close, the warming Earth was suddenly plunged back into a period of intense cold. Across North America and parts of Europe, temperatures dropped abruptly, glaciers advanced once more, and thriving ecosystems collapsed without warning. To early human communities, the transformation would have seemed apocalyptic. What had once been fertile hunting grounds turned into frozen wastelands. The shift was so sudden and severe that it defied the natural rhythms of climate. Something catastrophic had interrupted the planet's recovery, and according to one controversial theory, the cause may have fallen from the sky. Known as the Younger Dryas impact hypothesis, this theory proposes that fragments of a comet or asteroid struck the Earth approximately 12,900 years ago. The proposed impact did not leave behind a single massive crater, but instead scattered debris across vast regions of the northern hemisphere. Researchers have identified unusual geological markers within a distinct layer of sediment known as the Younger Dryas boundary. Embedded within this layer are microscopic diamonds called nanodiamonds, high concentrations of iridium, and metallic spherules formed under extreme heat. These materials are commonly associated with cosmic impacts, suggesting that a catastrophic extraterrestrial event may have ignited widespread devastation. Further evidence points to massive wildfires that swept across continents. Charcoal deposits found within ancient soils indicate that vast forests burned simultaneously, releasing enormous quantities of smoke and ash into the atmosphere. This sudden injection of particulates may have blocked sunlight, triggering rapid cooling and ushering in a millennium-long return to glacial conditions. The resulting environmental upheaval would have decimated plant and animal life, disrupting food sources and forcing early human populations to adapt or perish. Among the most intriguing aspects of this period is the disappearance of the Clovis culture, one of the earliest known human societies in North America. Renowned for their distinctive fluted spear points, the Clovis people vanished from the archaeological record around the same time the Younger Dryas began. While some researchers attribute their disappearance to climate change or overhunting, others suggest that the proposed cosmic catastrophe played a decisive role. If true, the event may have not only reshaped the environment, but also altered the trajectory of human history. Yet the hypothesis remains fiercely debated. Critics argue that the evidence for a widespread impact is inconclusive, pointing to the absence of a definitive crater and questioning the interpretation of geological data. Supporters, however, continue to uncover new findings, including platinum anomalies and melt glass fragments consistent with extreme thermal events. Each discovery adds another layer of intrigue, keeping the mystery alive within the scientific community. What is certain is that the Younger Dryas represents one of the most abrupt climate reversals in Earth's history. Within a matter of years, the warming planet was thrust back into icy conditions that lasted over 1,000 years. For early humans, survival demanded resilience, innovation, and migration into unfamiliar territories. Entire ecosystems collapsed, and the balance of life was rewritten in an instant. If a cosmic impact truly triggered this catastrophe, it would mean that humanity's survival was once determined by forces beyond its control, celestial events unfolding in the silent darkness of space. And if such an event occurred once, it raises an unsettling possibility. Was the Younger Dryas merely a climatic anomaly, or the lingering scar of a forgotten cosmic disaster that nearly erased humanity from existence? The Glacial Maximum Crisis. In 26,500 BC, during the height of the last glacial maximum, vast sheets of ice stretched across continents, transforming the Earth into an unforgiving, frozen world. Towering glaciers advanced relentlessly, burying landscapes beneath layers of ice that rose thousands of feet into the sky. From North America to Northern Europe and across Asia, entire regions vanished beneath a silent, creeping force of nature. For early human populations scattered across the planet, survival was no longer a certainty. It was a daily struggle against extinction. The last glacial maximum marked the coldest phase of the most recent ice age. Temperatures in many regions dropped by as much as 10 to 15 degrees Fahrenheit below modern averages. Massive ice sheets, including the Laurentide ice sheet in North America and the Fennoscandian ice sheet in Europe, locked up enormous volumes of the Earth's water. As a result, sea levels fell by more than 400 feet, exposing vast land bridges such as Beringia, which connected Siberia to Alaska. These newly revealed corridors would become lifelines for migrating human populations seeking refuge from the encroaching cold. Yet the exposed terrain offered no guarantee of survival. The environment was harsh, windswept, and barren. Blizzards swept across open plains, while permafrost hardened the soil, making plant growth scarce. Food chains collapsed under the strain of extreme climatic conditions. Herds of mammoths, bison, and woolly rhinoceroses roamed the icy steppes, and human survival depended on the ability to hunt these formidable creatures. Failure meant starvation. Archaeological evidence reveals the resilience of early Homo sapiens during this period. Stone tools, animal bones, and remnants of primitive shelters discovered across Eurasia indicate that humans adapted with remarkable ingenuity. They crafted clothing from animal hides, constructed shelters from mammoth bones, and mastered the controlled use of fire. These innovations allowed them to endure temperatures that would have otherwise proven fatal. Survival was not a matter of dominance, but of adaptation. However, genetic studies suggest that the human population during this period may have dwindled significantly. Isolated by glaciers and harsh terrain, Small groups were forced into environmental refuges in regions such as southern Europe, Central Asia, and parts of Africa. These refugia became sanctuaries where humanity endured, while vast portions of the planet remained uninhabitable. The fragmentation of populations shaped human genetic diversity, leaving traces that scientists continue to study today. Despite these discoveries, questions remain. Some researchers argue that the last glacial maximum nearly drove early human populations to extinction, while others contend that it served as a crucible that strengthened humanity's resilience. Evidence from ancient DNA and archaeological records paints a picture of hardship, migration, and survival against overwhelming odds. But the full extent of the crisis remains buried beneath ice and time. As glaciers advanced and retreated, they reshaped rivers, carved valleys, and altered the geography of entire continents. When the ice eventually melted, it gave rise to new ecosystems and opportunities for human expansion. Yet the scars of the Ice Age endured, etched into the genetic and cultural history of our species. If the ice had advanced just a little farther, or if the cold had persisted a little longer, the fragile populations of early Homo sapiens might have vanished forever. Civilization, language, and history as they are known today would never have existed. Did humanity conquer the Ice Age through intelligence and resilience? Or did it merely survive by finding refuge in the narrowest margins of a frozen world? The Laschamp magnetic reversal. In 40,000 BC, deep within ancient lava flows near the village of Laschamp in central France, a silent anomaly was sealed into stone. When geologists first examined the basalt in the 20th century, they discovered something unsettling. The magnetic signatures preserved within the rock were reversed, pointing south instead of north. This was not a localized irregularity. It was evidence that the Earth's magnetic field had dramatically weakened and partially flipped. For a brief but catastrophic period in prehistory, the invisible shield protecting life on Earth had faltered, and when it did, the consequences may have pushed humanity to the brink of extinction. Known as the Laschamp geomagnetic excursion, this event occurred approximately 42,000 years ago. During this period, the Earth's magnetic field weakened to as little as 5 to 10% of its current strength. Normally, this magnetic barrier deflects harmful solar radiation and cosmic rays. Without it, the planet was left dangerously exposed. Charged particles from the sun penetrated deeper into the atmosphere, disrupting climatic systems and increasing radiation levels across the globe. The skies may have glowed with intense auroras visible even near the equator, a breathtaking spectacle masking a growing environmental crisis. Scientific evidence supporting this event has been uncovered across multiple continents. Magnetized volcanic rocks, ocean sediment cores, and ancient stalagmites all preserve traces of the magnetic instability. Ice cores extracted from Greenland and Antarctica reveal spikes in cosmogenic isotopes, such as beryllium-10, indicating increased cosmic radiation during the period. These findings suggest that the weakening of the magnetic field allowed high-energy particles to bombard the Earth's surface at unprecedented levels, altering atmospheric chemistry and potentially depleting the ozone layer. Recent studies have linked this period of magnetic instability to widespread environmental upheaval. Computer simulations indicate that disruptions in atmospheric circulation may have triggered rapid climate fluctuations, intensifying already harsh Ice Age conditions. As ultraviolet radiation increased, ecosystems faced unprecedented stress. Animal populations declined, vegetation patterns shifted, and survival became increasingly uncertain for early humans struggling to endure a volatile world. Some researchers have proposed an even more provocative hypothesis. The Laschamp event coincides roughly with the disappearance of Neanderthals from Europe. While multiple factors likely contributed to their extinction, including competition with Homo sapiens and changing climates, increased radiation exposure, and environmental instability may have played a role. If true, the weakening of Earth's magnetic shield could have altered the course of human evolution, shaping which species survived and which vanished into history. Archaeological discoveries from this era reveal subtle yet significant changes in human behavior. Around this time, early Homo sapiens began producing cave art, personal ornaments, and tailored clothing, Some scientists speculate that these innovations were adaptive responses to increased ultraviolet radiation and harsher environmental conditions. The use of ochre as a protective pigment and the expansion of cave habitation may not have been purely cultural developments, but necessary strategies for survival in a world suddenly more hostile. Despite mounting evidence, the full impact of the Laschamp geomagnetic excursion remains a subject of ongoing debate. There is no definitive proof that it triggered mass extinctions or directly threatened humanity's survival. Yet the convergence of geological, climatic, and archaeological data suggests a period of extraordinary instability. It was a time when the Earth's natural defenses faltered, leaving life exposed to forces far beyond human control. If the magnetic field had collapsed entirely instead of briefly weakening, the consequences might have been catastrophic. Radiation levels could have surged, ecosystems might have collapsed, and early human populations may have faced extinction. The survival of Homo sapiens may have depended not on strength or intelligence alone, but on the fortunate restoration of a planetary shield invisible to the naked eye. Today, scientists continue to monitor fluctuations in the Earth's magnetic field, aware that it is neither permanent nor unchanging. The Laschamp event stands as a haunting reminder that the stability of our world is fragile and temporary. If the Earth's protective shield failed once before, leaving humanity exposed to the cosmos, what would happen if it failed again? The Megafauna Extinction. In 12,000 BC, as the last ice age drew toward its end, the Earth witnessed one of the most profound ecological upheavals in its history. Across vast continents, creatures of unimaginable size began to vanish. Woolly mammoths collapsed onto frozen tundras, saber-toothed cats disappeared into silence, and giant ground sloths that once roamed ancient forests faded from existence. These were not isolated extinctions. They unfolded across North America, Eurasia, Australia, and South America with startling speed. For early human societies, the disappearance of these colossal animals signaled not only the end of an era, but the beginning of a crisis that threatened their survival. The late Pleistocene megafauna collapse marked the extinction of animals weighing over 100 pounds. Among them were mastodons, woolly rhinoceroses, giant kangaroos, cave bears, and the formidable American lion. Fossil records indicate that approximately 65% of large mammal species in North America disappeared during this period. In Australia, the extinction rate reached nearly 90%. Such widespread losses reshaped ecosystems and disrupted food chains that had endured for millennia. The sudden absence of these dominant species created an ecological vacuum with consequences that echoed throughout the natural world. Scientists have long debated the cause of this mass extinction. One prevailing theory attributes it to rapid climate change at the end of the Ice Age. As glaciers melted and temperatures rose, ancient habitats transformed. Grasslands gave way to forests, and once familiar environments became unrecognizable. Species unable to adapt to these changes faced inevitable decline. Yet climate alone may not fully explain the sudden disappearance of so many large animals. Another theory places early humans at the center of the catastrophe. Known as the overkill hypothesis, it suggests that the arrival of skilled hunters armed with advanced stone tools and cooperative strategies accelerated the extinction of megafauna. Archaeological evidence reveals spear points embedded in fossilized bones, indicating that humans hunted mammoths and other giants. These animals reproduced slowly, and sustained hunting pressure may have driven them to extinction within centuries. If true, the collapse represents one of the earliest examples of humanity's transformative impact on the planet. A third possibility links the extinction to a combination of environmental stress and human expansion. Some researchers propose that climatic instability weakened megafaunal populations, making them more vulnerable to hunting and ecological disruption. Others have suggested more controversial explanations, including disease or the aftermath of a cosmic event associated with the younger Dryas period. While these hypotheses remain debated, the timing and scale of the extinctions continue to perplex scientists. For prehistoric humans, the consequences were immediate and severe. The loss of megafauna meant the disappearance of essential sources of food, clothing, tools, and shelter. Mammoth bones had been used to construct dwellings, hides provided insulation against the cold, and meat sustained entire communities. As these resources dwindled, early humans were forced to adapt or perish. This crisis may have driven the transition from large game hunting to more diversified diets, encouraging innovation in tool-making, agriculture, and social organization. In this sense, the extinction reshaped not only ecosystems, but the trajectory of human civilization itself. Evidence of these vanished giants lies preserved in permafrost, tar pits, and ancient sediments. Perfectly preserved mammoth carcasses discovered in Siberia still contain remnants of fur and stomach contents, offering haunting glimpses into a lost world. Each discovery deepens the mystery, revealing how abruptly these creatures disappeared from the Earth. Despite decades of research, the precise cause of the megafauna collapse remains unresolved. Was it climate, human activity, or a catastrophic convergence of both? The answer continues to elude definitive proof, leaving behind a puzzle etched into the fossil record. If the disappearance of the world's largest animals was a warning rather than an ending, it raises a chilling possibility. When the giants fell, humanity stood alone at the top of a fragile ecosystem. But was their extinction a triumph of human adaptation, or the first sign of a species capable of reshaping the planet to its own peril? The Pleistocene volcanic winters. In 43,000 BC, a violent eruption tore through the crust of the Earth near what is now Naples, Italy. Known today as the Campanian ignimbrite eruption, it was one of the most powerful volcanic events of the last 200,000 years. Columns of ash and molten debris surged more than 25 miles into the atmosphere, spreading darkness across Europe and beyond. The explosion unleashed over 70 cubic miles of volcanic material, burying landscapes beneath layers of ash and igniting environmental chaos on a continental scale. For early human populations scattered across Eurasia, it marked the beginning of a prolonged struggle for survival. The immediate devastation was catastrophic. Pyroclastic flows, moving at hundreds of miles per hour and reaching temperatures exceeding 1,000 degrees Fahrenheit, incinerated everything in their path. Entire ecosystems were annihilated within hours. Ash clouds drifted across the skies, blotting out sunlight and plunging regions into an eerie twilight. Fine particles of volcanic dust settled across vast territories, contaminating water sources, suffocating vegetation, and disrupting food chains essential to both animals and humans. Geological evidence reveals the immense reach of this eruption. Layers of Campanian ignimbrite ash have been discovered as far away as Russia and the eastern Mediterranean. Sediment cores and volcanic deposits confirm that the eruption triggered severe climatic disturbances. As sulfur dioxide and ash entered the stratosphere, they reflected solar radiation back into space, initiating a volcanic winter. Global temperatures dropped sharply, intensifying already harsh ice age conditions. This sudden cooling disrupted ecosystems, causing widespread famine among animal populations and forcing human communities to confront a rapidly deteriorating environment. Archaeological findings suggest that the eruption coincided with significant changes in prehistoric human populations. In Europe, the event aligns closely with the decline of Neanderthals. Some researchers hypothesize that the environmental stress caused by the eruption weakened Neanderthal communities, leaving them vulnerable to extinction. Meanwhile, Homo sapiens, equipped with advanced tools, social cooperation, and adaptive strategies, may have been better suited to survive the crisis. Though debated, this theory underscores the potential evolutionary consequences of catastrophic volcanic winters. Beyond immediate destruction, the lingering effects of volcanic winters posed long-term challenges. Reduced sunlight hindered plant growth, leading to food shortages that cascaded through entire ecosystems. Herbivores struggled to find nourishment, while predators faced dwindling prey. For human populations, survival required mobility, ingenuity, and resilience. Evidence suggests that groups migrated in search of habitable refuges, altering patterns of settlement and accelerating cultural development. The Campanian ignimbrite eruption was not an isolated phenomenon. Throughout the Pleistocene epoch, multiple large-scale volcanic events released ash and aerosols into the atmosphere, contributing to cycles of climatic instability. Ice core analyses from Greenland and Antarctica reveal traces of volcanic activity that correspond with abrupt temperature fluctuations. These findings suggest that prehistoric humanity endured repeated episodes of environmental stress, caused by explosive eruptions and prolonged volcanic winters. Despite compelling evidence, the precise impact of these events on early human populations remains a subject of scientific debate. Some researchers argue that volcanic winters pushed humanity to the brink of extinction, while others believe they served as catalysts for adaptation and innovation. The truth likely lies somewhere between catastrophe and resilience, hidden within the geological record. What is certain is that these eruptions demonstrated the fragile balance upon which human survival depended. A single eruption could darken the skies, disrupt climates, and reshape the course of evolution. Had such events been slightly more severe or more frequent, the lineage of Homo sapiens might never have endured. If the Earth once plunged into darkness under clouds of volcanic ash, threatening the very existence of humanity, it raises an unsettling question. Did our ancestors survive these volcanic winters through ingenuity and endurance, or because the planet spared them from a catastrophe just shy of extinction? The prehistoric megadroughts. In 70,000 BC, vast regions of Africa began to transform under a relentless and silent force. Rainfall diminished, rivers shrank into trickles, and once lush grasslands gradually turned into barren deserts. What had once been fertile corridors of life became inhospitable expanses of dust and stone. For early Homo sapiens, whose survival depended on predictable water sources and migratory wildlife, the change was catastrophic. As drought tightened its grip on the land, humanity faced a crisis that threatened not just communities, but the very continuity of the species. This period, often associated with severe climatic instability during marine isotope stage 4, marked one of the harshest environmental challenges faced by early humans. Geological and paleoclimatic evidence reveals prolonged cycles of aridity across eastern and northern Africa. Lake beds evaporated, leaving behind layers of salt and sediment that today serve as silent witnesses to ancient desolation. Sediment cores extracted from the Horn of Africa and the Sahara Desert indicate dramatic fluctuations in rainfall, suggesting that prolonged droughts may have forced early human populations into isolated pockets of habitable land. The consequences of these megadroughts were devastating. As vegetation withered, herbivores migrated or perished, disrupting fragile food chains. With game becoming scarce and water sources dwindling, early humans were compelled to abandon ancestral territories in search of survival. Archaeological evidence points to the emergence of migratory corridors, particularly along coastal regions and river valleys, where freshwater and marine resources offered a lifeline. These routes may have facilitated the first major dispersals of Homo sapiens out of Africa and into the wider world. One of the most compelling theories linked to these droughts is the population fragmentation hypothesis. Genetic studies reveal that early human populations experienced significant bottlenecks, suggesting periods when survival was restricted to a handful of environmental refugees. Coastal areas, such as those along southern Africa, may have provided critical sanctuaries. Here, access to shellfish and other marine resources enabled small groups to endure conditions that would have otherwise proved fatal. These refugia were not merely shelters. They were crucibles of human innovation and resilience. Scientific investigations continue to uncover evidence supporting these dramatic climatic shifts. Isotopic analyses of ancient stalagmites in caves across Africa and the Middle East reveal prolonged periods of reduced rainfall. Similarly, fossil pollen records indicate abrupt changes in vegetation patterns, confirming transitions from humid landscapes to arid deserts. These environmental transformations reshaped ecosystems on a continental scale, dictating the movements and survival strategies of early human populations. Yet the extent to which these megadroughts threatened humanity remains a subject of debate. Some researchers argue that such climatic extremes nearly drove Homo sapiens to extinction, while others believe they served as catalysts for migration and adaptation. What is undisputed, however, is their role in shaping the evolutionary trajectory of our species. These droughts compelled early humans to innovate, cooperate, and explore unfamiliar territories, laying the foundations for the global spread of humanity. Evidence of ancient drought cycles is etched into the geological record of the Sahara, which has alternated between verdant savanna and desolate desert over thousands of years. During its arid phases, inhospitable conditions would have formed formidable barriers to migration, isolating populations, and intensifying survival pressures. Such environmental challenges tested the limits of human endurance in ways that are difficult to imagine today. If these megadroughts had persisted slightly longer, the fragile human populations of prehistoric Africa might have vanished without a trace. Civilization, culture, and history as they are known today could have been erased before they ever began. Were these ancient droughts merely natural climatic cycles, or were they pivotal trials that determined whether humanity would endure or disappear? The ancient sea level rise. In 12,000 BC, as the last ice age drew to a dramatic close, the world began to thaw. Colossal glaciers that had dominated the northern continents for tens of thousands of years started to melt, releasing unimaginable volumes of water into the oceans. What followed was not a gradual transformation, but a relentless rise of the seas. Coastlines vanished, fertile plains disappeared beneath waves, and entire landscapes were erased from existence. For prehistoric humans who had settled along rivers and shorelines, the encroaching waters marked the beginning of a catastrophe that reshaped the course of human history. Scientific evidence reveals that global sea levels rose more than 400 feet from the peak of the last glacial maximum to the early Holocene. This transformation inundated millions of square miles of habitable land. Regions that once connected continents were swallowed by the ocean. Among them was Beringia, the vast land bridge that had allowed early humans to migrate from Asia into North America. As the seas advanced, this critical corridor disappeared forever, isolating populations and altering the trajectory of human migration. One of the most dramatic episodes during this period is known as Meltwater Pulse 1A, which occurred approximately 14,600 years ago. During this event, sea levels surged at astonishing speeds, rising by as much as 60 feet within a few centuries. To early coastal communities, such a rapid increase would have appeared apocalyptic. Entire settlements would have been forced inland as shorelines retreated year by year. Forests drowned, freshwater systems were contaminated with salt, and fertile plains that once supported life were consumed by the ocean's advance. Geological and archaeological discoveries provide compelling evidence of these ancient inundations. Submerged landscapes have been identified beneath the North Sea, an area now known as Doggerland. Once a vast and fertile expanse connecting Britain to mainland Europe, Doggerland was home to prehistoric hunter-gatherers. Today, its remains lie buried beneath layers of sediment, occasionally revealed by fishing nets that dredge up ancient tools and fossilized bones from the seafloor. These relics serve as haunting reminders of a world lost to the rising tides. Further evidence emerges from submerged ruins discovered in various parts of the world. Off the coasts of India and Japan, researchers have identified structures and formations that some interpret as remnants of ancient human activity. While their origins remain debated, they fuel speculation that prehistoric settlements may have been engulfed by rising seas. These findings blur the line between archaeology and legend, hinting that humanity's earliest chapters may rest beneath the ocean's depths. The consequences of rising sea levels extended beyond physical displacement. As coastal regions flooded, human populations were forced to migrate inland, leading to competition for resources and the reshaping of early societies. These migrations likely influenced cultural exchanges, technological innovations, and the spread of knowledge. In this way, catastrophe became a catalyst for transformation, compelling humanity to adapt to an ever-changing world. Some researchers have drawn connections between these ancient floods and the widespread myths of a great deluge found in cultures across the globe. From Mesopotamia's Epic of Gilgamesh to later flood narratives, such stories may echo collective memories of real prehistoric events. Whether symbolic or historical, these legends suggest that the trauma of rising seas left an enduring imprint on human consciousness. Despite decades of research, the full extent of prehistoric coastal inundation remains unknown. Vast portions of ancient shorelines now lie hidden beneath the ocean, beyond the reach of conventional archaeology. Each new underwater discovery raises further questions, revealing how much of humanity's early history may have been swallowed by the sea. If the oceans had risen more rapidly, or if humanity had failed to adapt, the fragile populations of early Homo sapiens might have disappeared along with their submerged homelands. Entire chapters of human existence now lie entombed beneath the waves, lost to time. Did our ancestors survive this ancient deluge through ingenuity and resilience? Or are the world's flood myths echoes of a catastrophe that nearly erased humanity from the earth? The prehistoric Great Flood. In 5600 BC, along the fertile shores of what is now known as the Black Sea, an event of unimaginable scale may have unfolded. According to a controversial scientific theory, a massive wall of seawater surged through the Bosporus Strait, violently transforming a once isolated freshwater lake into a vast inland sea. As the Mediterranean breached its natural barrier, the incoming torrent is believed to have cascaded with overwhelming force, submerging ancient settlements and permanently altering the landscape. For the early human communities who inhabited the region, the rising waters would have appeared sudden, unstoppable, and apocalyptic. If true, this catastrophe may have inspired one of humanity's most enduring legends, the story of a great flood. This theory, widely known as the Black Sea Deluge hypothesis, was popularized in the late 20th century by marine geologists William Ryan and Walter Pittman. Their research suggested that the Mediterranean Sea, swollen by post-Ice Age glacial melt, eventually breached a natural land barrier at the Bosporus. When the barrier collapsed, seawater is believed to have poured into the Black Sea basin with immense force. Some estimates propose that the flood advanced at rates covering miles of land each day, inundating vast coastal plains. If accurate, the event would have displaced thousands of prehistoric inhabitants, forcing them to flee inland in search of survival. Geological evidence offers intriguing support for this hypothesis. Sediment cores extracted from the floor of the Black Sea reveal a sharp transition from freshwater to saltwater deposits, indicating a dramatic environmental transformation. Marine shells found atop ancient freshwater sediments suggest that seawater rapidly replaced a once stable ecosystem. Sonar scans have also identified submerged shorelines and ancient river channels deep beneath the Black Sea's surface, implying that the region was once dry land. These findings lend credibility to the possibility of a catastrophic inundation that reshaped both geography and human history. Underwater archaeological discoveries have further fueled speculation. In 2000, an expedition led by renowned ocean explorer Robert Ballard identified submerged structures and preserved organic materials resting on the Black Sea seabed. Among these discoveries were remnants resembling wooden constructions and signs of ancient habitation. Although interpretations remain debated, such findings suggest that prehistoric communities may have once occupied areas now lost beneath the waves. Each discovery deepens the mystery, blurring the line between legend and reality. Beyond geological and archaeological evidence, the narrative of a great flood appears across civilizations separated by vast distances and epochs. The Epic of Gilgamesh recounts a deluge sent by the gods to cleanse the world. The biblical story of Noah describes a cataclysm that destroyed nearly all life. Greek mythology tells of Deucalion and Pyrrha, survivors of a divine flood. Similar traditions exist in ancient India, China, and the Americas. The striking similarities among these accounts have led some scholars to speculate that they may preserve cultural memories of real prehistoric disasters. Yet the Black Sea Deluge hypothesis remains controversial. Critics argue that the flooding occurred more gradually than originally proposed, suggesting a slow marine transgression rather than a sudden cataclysm. Others question the scale of its impact on human populations. Despite these debates, the evidence continues to provoke fascination and inquiry, ensuring that the mystery remains unresolved. If a catastrophic flood truly reshaped the Black Sea region, its impact on early human societies would have been profound. Entire communities may have been displaced, carrying their memories and stories across continents. Over generations, these recollections could have evolved into myths that echoed through history, eventually recorded as sacred texts in ancient epics. If the Great Flood was not merely legend, but a memory of survival etched into human consciousness, it raises a haunting possibility. Beneath the world's oldest stories may lie the remnants of a disaster that nearly erased our ancestors from existence. Did humanity inherit these flood myths as symbolic tales of morality, or as fragmented memories of a prehistoric catastrophe too immense to forget? The Prehistoric Pandemic hypothesis. In 30,000 BC, long before the first cities were built, or the earliest records etched into stone, an invisible enemy may have swept silently across the fragile populations of prehistoric humanity. There were no written accounts, no surviving testimonies, and no chronicles of the dead. Yet, hidden within ancient bones and encoded deep within human DNA, lies evidence suggesting that disease may have once threatened to extinguish our species. Unlike volcanic eruptions or cosmic impacts, this catastrophe left no crater, no ash layer, and no monument of destruction. Its traces were microscopic, silent, and nearly erased by time. For decades, scientists believed that pandemics emerged only after the rise of agriculture, when dense settlements and domesticated animals facilitated the spread of infectious diseases. However, advances in paleogenetics have challenged this assumption. Using sophisticated techniques to extract ancient DNA from prehistoric skeletons, researchers have uncovered genetic remnants of pathogens dating back tens of thousands of years. These discoveries reveal that early humans were not strangers to infectious disease. They lived, suffered, and died under the shadow of microscopic threats long before recorded history began. Among the most compelling findings is evidence of ancient bacterial infections preserved in fossilized remains. DNA fragments of pathogens related to modern tuberculosis and brucellosis have been identified in prehistoric bones, suggesting that early humans faced chronic illnesses capable of weakening populations over generations. More strikingly, studies have detected ancient strains of Yersinia pestis, the bacterium responsible for the plague, dating back thousands of years before historically documented pandemics. These primitive strains may not have caused the rapid outbreaks known from medieval history, but they indicate that deadly diseases were already circulating among ancient human populations. Genetic research provides further clues. The human genome contains adaptations linked to immune responses against infectious diseases, suggesting that our ancestors endured repeated epidemics severe enough to influence natural selection. Certain genetic mutations associated with disease resistance appear to have spread rapidly through early populations, implying intense evolutionary pressure. These adaptations hint at catastrophic outbreaks that may have decimated communities, leaving only those with advantageous immunity to survive. Archaeological discoveries reinforce this possibility. Mass burial sites from prehistoric periods reveal unusually high mortality rates, though the exact causes often remain uncertain. Some skeletal remains show lesions consistent with infectious disease, while others indicate sudden and widespread death. Without written records, the true scale of these events remains speculative. Yet the patterns suggest that ancient epidemics may have periodically swept through small and isolated populations, pushing them dangerously close to extinction. The vulnerability of prehistoric humans would have amplified the impact of disease. Nomadic groups lacked medical knowledge, immunity, and the means to contain outbreaks. A single infection could spread rapidly through tightly knit communities, leaving devastation in its wake. Unlike modern pandemics, there were no treatments, no quarantines, and no understanding of contagion, only survival or extinction. In such fragile conditions, even a localized epidemic could have erased entire groups from the genetic record. Despite mounting evidence, the concept of prehistoric pandemics remains a subject of ongoing scientific debate. The scarcity of preserved remains and the degradation of ancient DNA make definitive conclusions difficult. Some researchers argue that infectious diseases became widespread only after the advent of agriculture, while others contend that epidemics predated civilization itself. As technology advances, new discoveries continue to reshape our understanding of humanity's ancient struggles against disease. If a prehistoric pandemic once swept across the Earth, it would have left few visible traces, only silent gaps in the archaeological record and subtle imprints within our genetic code. Unlike other catastrophes, its devastation would have been invisible, remembered not in monuments or myths, but in the fragile resilience of those who survived. If humanity truly endured an ancient pandemic long before history began, it raises a chilling question. Did our ancestors survive because of their adaptability, or because a microscopic adversary spared just enough lives for our species to endure? Conclusion: these prehistoric catastrophes reveal a chilling and unmistakable pattern. From supervolcanic eruptions and cosmic impacts to geomagnetic instability, megafaunal collapse, and ancient pandemics, each event represents a moment when humanity stood on the precipice of extinction. These were not isolated disasters scattered randomly across time. They were existential trials that repeatedly tested the resilience of our species, shaping the fragile path of human survival. Together, they form a narrative not merely of destruction, but of endurance against forces far beyond human control. Scientific evidence suggests that early Homo sapiens survived a series of environmental crises capable of reshaping ecosystems and altering the course of evolution. Geological records, genetic bottlenecks, and archaeological discoveries point to periods when human populations dwindled to dangerously low numbers. Entire communities vanished, and the continuity of our species hung by a thread. Each catastrophe forced adaptation through migration, innovation, and cooperation. Humanity did not rise in a stable world. It emerged from chaos, forged in the crucible of disaster. Yet beneath this narrative of resilience lies a deeper and more unsettling implication. These events were not anomalies. They were part of recurring natural cycles, volcanic winters, abrupt climate shifts, and celestial threats that continue to shape the Earth today. Supervolcanoes remain active beneath our feet. Asteroids still traverse the silent expanse of space. Magnetic fluctuations persist within the planet's core. Ancient pathogens, once thought extinct, have been detected in melting permafrost. The forces that once threatened to erase humanity have not vanished. They endure, waiting beyond the boundaries of prediction and control. The consequences of these prehistoric disasters extended far beyond survival. Each catastrophe reshaped migration patterns, accelerated technological innovation, and altered the trajectory of human evolution. Entire chapters of history were lost before they could be written. Submerged coastlines conceal the remnants of forgotten settlements, while gaps in genetic records hint at populations erased without a trace. Every vanished culture represents a story buried beneath layers of ash, ice, and sediment. Each extinction is a reminder of how narrowly humanity escaped oblivion. These events also expose the fragile illusion of permanence. Civilization often assumes stability as its foundation, yet the past reveals a different truth. Our species survived not because the world was safe, but because it was unpredictable. Survival depended on adaptation, ingenuity, and perhaps moments of extraordinary fortune. The boundary between existence and extinction has always been perilously thin. Today, modern science allows humanity to study and anticipate many of these threats. Satellites monitor near-Earth objects, volcanologists track restless supervolcanoes, and climatologists analyze shifts in global temperatures. Yet, despite technological advancements, the ultimate power of nature remains uncontested. The same forces that nearly wiped out our ancestors still exist, reminding us that survival is not guaranteed, but earned. The prehistoric past offers a sobering lesson. Humanity is not invincible. It is the survivor of a long series of catastrophes that could have ended its story before it truly began. Every breath, every civilization, and every discovery stands as a testament to ancestors who endured when extinction seemed inevitable. The question is no longer whether humanity has faced annihilation before. The question is whether, when the next catastrophe arrives, we will be prepared to survive it.